In this video, we're going to be talking about how we calculate our expected values for a chi-squared test for independence. The first step we take is we actually copy over the contingency table we're going to be using. This table on the top left corner here is from the first example on your follow along worksheet, and it looks at whether or not severe reactions in children is related to where they receive a vaccine or a shot. That is thigh and arm, and yes or no for a severe reaction. I'm going to start by copying the table over. So yes and no, thigh and arm, and then as always my last column and last row is always my total. What I do next is I copy over the totals, and that's it. I can't change the fact that this study looked at 13,810 children. I can't change the fact that 8,992 of them had an injection in the arm. Same up here. And my totals down here as well. So I keep my group totals. Now to figure out where I'm going from here, I need to remember that my null hypothesis in a chi-squared test for independence is that my variables are in fact independent. And if I'm assuming things are independent, I can think back to my probability, which tells me that the probability of A and B is equal, if these two are independent, to the probability of A times the probability of B. This is really nifty because it allows me to do things like say, okay, I want the probability that yes, a child has a severe reaction and that their injection was in the thigh. Well, if these are independent, this is the same as the probability that yes, they have a severe reaction times the probability they have an injection in the thigh. I could find these values here based on my table. So the probability yes, a kid has severe reactions is 106 over 13,810. Once again, tracing that yes all the way down. And chances they have a thigh injection would be 4,818 over 13,810, tracing the row across. And what this would give me then is the probability that, yeah, a kid had a severe reaction and that their injection was in the thigh. Now, what I actually want to find in this specific instance is not this, but rather what goes right here. That is, I don't want the probability a kid has this happen. I want the number of kids that have this happen. Now, if I asked you what 10% was, you could find 10% of my sample size by taking 10% times the total, right? 10% of 13,810, which means if I give you this as a percentage measurement, you could find out how many kids fit in that category by taking that thing right there and multiplying it by 13,810, right? That is, if this is the percent who fit in this category, this will give me the number who fit in it. And that's because I'm taking a percentage times the overall total. Now we could actually calculate that, or we could look at this a little bit more in depth, and that is pulling it over on the side here. I notice I would have 106 over 13,810 times 4,818 over 13,810. And then if I want the number of people, I'd multiply that by 13,810. So again, this is the percent of people. And this right here is the total. So if I take the percent times the total, I'll get the number of people who fit in that category. Now I can actually simplify this algebra, and that is, you notice how I have a 13,810 at the end here? I can use that to cancel one of these, which means, in reality, this number right here, I could find it by taking 106 times 4,818, all divided by 13,810. Or if I'm going to go ahead and round, 36.98 to 2 decimal places. Now, I want to be clear here that I calculated this by once again taking the probability times number probability times overall total, but because we want to be able to do this for any contingency table, we should probably find a simpler way to do it. And the way we're going to do this is we're going to look at the individual parts here. So let's look at this 106 first. That 106 corresponded to the 106 here, and we used it because it was the total number of kids who, yes, had a severe reaction. That is, that 106 was my column total. So I have 106, which is my column total, and I multiply it by this 4818, and that 4818 came from over here, and what that corresponds to is actually my row total. So on the top, I have my column total times my row total. Now on the bottom, I ended up with this 13810. And that 13810 came from right here, which is my overall total. Or my sample size, if you'd prefer. This over here then gives me my formula to find any expected value on a contingency table for a chi-squared goodness of fit. Once I've got this number, notice I could repeat it for the rest of the cells, or I could just use the fact that it's additive. That is, to find this cell right here, I could just take 4818, the row total, minus 36.98 to find that one. I could then use subtraction and addition to find the rest of these. Now that we've got a formula, let's go ahead and practice using that formula.